This is the monthly space news covering the time roughly since the last meeting, about a month ago. And we'll just get right into it. First topic is winter is coming, delayed reference there, but it's coming to the Mars northern hemisphere. What does that mean? Well, it means that the days are shorter, so there's less solar input for the solar cells for any craft that are on the surface of Mars, which are still relying on solar cells. And there are multiple versions of those. Not so much the Perseverance rover, but some of the other things, which we'll get to here. So there's only two problems. One is the days are shorter, and the other is that there's typically more dust, and that's actually been a real problem for some of the craft that are on the surface right now. The big problem, of course, is you want to survive the night. You don't get sunlight during the nighttime, and they need the heat just to keep from freezing all the electronics. What does that affect? Well, first of all, it affects the Ingenuity Mars helicopter. That's a pretty low power operation. They did actually lose contact for a while. It got cold enough that the thing shut down and went into a safe mode. And they waited around. They realized that when it started back up, it wouldn't know what time it was. And it was just going to start transmitting. And they had to make a point to stop and just listen really carefully. They managed to reestablish communications with the Perseverance rover, which is a good thing. That's really the only way we have to communicate with. All the communications are via the Perseverance rover. They did change the operations a little bit. They used to start heating when you got down to about 5 degrees Fahrenheit. And now they've switched it so that they don't turn on the heater until it gets down to about -40. And that's Fahrenheit or centigrade is the same. So that's a move to conserve power, and it looks like that's worked. So they're letting it build back up, and they think they still have good contact with the helicopter. It also affects China's rover called the Zhurong. They've scaled back their operations. And the big one, the one that's in the most trouble, is the InSight lander. That landed in 2018. It was mostly for weather and seismic monitoring. They had a bunch of instruments on there. They've had a real problem in that the dust keeps building up on its solar cells. And a lot of the other rovers we've had, the winds eventually blew off a lot of that dust and it wasn't so bad. But where they are, they're in this big open flat plane. There's just not that much wind. And so the dust just keeps kind of building up and building up. And they've tried tricks like dropping coarser sand, using the robot arm, dropping it on the solar cells, and then the wind that is there is used to help blow it off. And that's helped. But they don't really think it'll last beyond this year, maybe not even through the summer. We'll see what happens. So it's scaled back. On the other hand, it did come back from a safe mode in January. And they turned off almost all of the scientific instruments, except for seismic monitoring, and which is a good thing because they did, in fact, manage to monitor the largest Marsquake they've seen yet at magnitude 5 on their scale. So they're still hoping that they can make this lander last through the end of the year. Maybe it will make it, maybe not.
Back to the previous slide.
Yeah.
So why did the China's Zhurong Mars rover operation scale back?
Well, they are based on solar cells also. So there's just a limited amount of power available, and they want to make sure they have enough to last the night. So that means they cut back on operations during the day, like driving, or maybe they don't use all the scientific instruments. And that's what they're doing on all of these. I mean, it's not unique to them, but they're all doing that. Next topic, nuclear thermal propulsion. This is basically, having an actual reactor in space. It is used to heat up a propellant, super hot, and it shoots out, so it comes out faster than it does from a chemical rocket. DARPA had done a variety of studies on this. Actually, NASA has done a variety of studies on this over time. Right now, they've already finished a phase 1 project, and they're advertising for proposals. So anybody in this room that wants to build a nuclear rocket, this is your chance. But you got to get your proposals in by August, so your time's a little tight. But they have a program. And this is sponsored by DARPA, Defense Advanced Research Projects Agency. These are the people that brought us the internet and a lot of the early automatic driving, kind of things. Typically, a lot of innovative stuff has come out of research that they have sponsored. And what they're doing right now is they're focusing on cislunar operations, meaning operations around between Earth and Moon. Their particular, interest, kind of from the military side, is if you have, some craft that are up there and need to go and do something in space, you may have very large orbital changes that are needed. And so they want to have a lot of power available, and they think they can do better with an atomic-based one. What they're shooting for is something that's comparable to chemical propulsion in terms of thrust, but maybe 2 to 5 times more efficient. And so the propellant they have would last a whole lot longer as a result. They have an engine design already based on Project General Atomics does. They're a contractor out of San Diego. They started off actually, obviously, in small atomic reactors. They do a lot of work for the Navy, also Predator drones and those kind of things. Yeah, proposals are due on the 5th. I put several sets of pictures up here. The big picture here is the one that's from DARPA, their concept of what something like this might look like. Quite often, you'll see this other one, the one over on the right-hand side over here, because NASA has a similar program going on. Their interest is not so much rapid maneuvering around Earth and the Moon. Their interest is getting to Mars faster. So they have a slightly different emphasis, but obviously they're still looking into the same kinds of technologies. But when you see that picture on the right, that's the one that NASA typically uses. To see the picture on the left, that's typically the DARPA project. Anyway, what's interesting about this one is they're actually hoping to get a demo flight in space by 2026. So they are moving along on this. Now, of course, we've talked about this a little bit before. There have been projects going on for quite a while, and we thought we were fairly close many, many years ago, but all those projects got dropped. Well, it seems like they're back in play right now. Next thing is there are some other government programs that are of interest. In fact, they're very small businesses. The Space Force seems like they're, in a way, they're kind of getting their act together on doing things. They have this project called Orbital Prime, and what their focus is on sustainable space technologies and architecture to support that. So their overall goals are really two-part. One, of course, is technology development, and their big theme is an acronym called OSAM, which stands for on-orbit servicing, assembly, and manufacturing. But there's a dual part to this. The other part of this is they see themselves as kind of priming the pump. They want to do things the way that NASA has done, for instance, with the CLIPS program for the moon and for commercial crew service, basically get more small-scale private industry involvement. And it's kind of a dual goal there, sort of a business goal and a technical goal. As their first project, they're promoting what they're calling active debris mediation, essentially orbital debris cleanup. One thing about this is they're talking about recycling or removing objects that are up there in space that are not wanted for various reasons. The key word they're emphasizing here is non-cooperating debris. And that's very different. We've talked before about the Japanese company Astroscale, which is trying to put up satellites. They have a plan where everything that goes up, every new satellite, would have a little metal plate on it and then special, some hardware and software to make it easy to mate with it and grab it and do something with it. But that doesn't really address the thousands of objects that are up in space already. This program is probably a lot more promising in that they're not assuming any cooperation whatsoever. A satellite could be dead, or any debris could be dead. It could be a piece of a rocket, whatever it is. You really need to solve the more general problem than just asking for things in particular. This diagram I have, there's a bigger picture. Their idea of space sustainability. I mean, they just break it out into simple terms where you approach an object, you acquire it, probably in most cases you grab a hold of it one way or another, and then you do whatever service is needed. Now that service might be repairing it, it might be recycling it or deorbiting it, whatever you're going to do. They don't put it on the slide, but hey, one of their options is vaporizing it if it's a small one. This is the terminology they're using, and they're just encouraging people to propose programs to help out in this process. But again, their overall goal is having sustainable space operations. They have a technology arm called SpaceWorks, and they have required the small businesses be a part of it and academics be a part of it as well. So it's kind of oriented towards starting off with small grants. A lot like the small business innovative research grants that NASA and other government agencies have done. They just awarded a bunch of phase 1 contracts, 125 of them. That seems like an awful lot, as a very large number. But these are teams typically composed of industries and academic partners. Each team got $250,000 to work with, basically promoting concepts and early design work. That's about $31 million right there. They only have 150 days to come up with their proposal that they're getting paid for, basically doing early design work. But more importantly, they'll be whittling it down, and then the phase 2 and phase 3 start, where there's actually much bigger funding. And in particular, their idea on the funding is it won't all be government financing, there'd be private investors involved as well. So again, they're trying to suck in, taking advantage of some of the advantages we have in this country where there's a lot of private capital involved, just as has happened, in a lot of other new space kind of activities. They want to tie into that really. Overall, they're looking at maybe $100 million kind of a project here. But they're hoping to have in-space demos within 2 to 4 years. So again, their timescales are relatively short compared to a lot of traditional space programs that happened in the past. Okay, and a little different topic here. Scientists, this is University of Florida, have now grown plants in lunar regolith. And I actually put in parentheses, despite lunar regolith, because if you read the paper, you can look at it here. I have it in the bottom of this particular slide. You can go get that. It's an open access paper. They've been trying to do this for about 10 years. And they proposed to NASA, give us some of your soil, we'll try growing some stuff in it. Basically, nobody was interested for the longest time. I think nobody really thought we were going back to the moon, so why bother? And now things are heating up again. People are getting interested in the moon again, so we're now getting funding involved in this. So NASA funded them, and the funding included, money to pay for the research, but also it included giving them actual lunar regolith that was collected during 3 of the Apollo missions. They gave them 12 grams of stuff from 3 different missions and told them to, do what they could with it. Now, this is a first, surprisingly, perhaps. You think, well, we've been talking about going to the moon for a long time. Surely somebody must have done this before. Nope, it really hadn't been done. When we first came back from the moon, everything was quarantined, and they tried experiments like taking some lunar dust, sprinkling it on existing living plants just to make sure it wouldn't kill them, because they were worried about maybe there were pathogens of some unknown origin. So they got past that stage. But ever since then, there have been a whole variety of experiments growing plants in simulated versions of lunar regolith or Mars, but it's all simulated, not real. So this is a little different, because it is actually quite different than Earth dirt, Earth soil, for one thing. There's microorganisms in the Earth stuff. There's a lot of carbon materials. The big thing is there's a lot of elemental iron that you don't have on Earth because it'd be oxidized and nothing else. A lot of the minerals are different, things like cadmium and that are really not very good for you. There's tiny abrasive glass particles, the thing that causes so much trouble with all the lunar exploration. So all that stuff's in there. It's a little different. And Johnson Space Center does provide an Earth-based volcanic simulant of lunar soil, but it's not really the same thing. It doesn't have some of those characteristics. So that's why they wanted to test it in lunar soil. So what they did is they planted the seed, they put them in little 1-gram containers with water, nutrients, and light. They have a particular plant they like to use. It's a form of watercress. It's in the mustard family. The reason they like to use that is that its genetic code has been fully mapped. And so if you want to see how do plants respond, they actually analyze it by looking at the gene expression. What happened? What did the plant actually do in response to its environment? It has the advantages also similar to many crop plants, and they have done experiments on the space station using the same plant. So they have a lot of good reasons for using this one. The thing about this, though, is that really that regolith, it was not used for the nutrients. It wasn't used like regular dirt. It was basically just a substrate. Essentially, they're doing hydroponic growth. And it turns out that it will grow better. And you can kind of see this on the slide here. On the left-hand side of this picture, these are plants that were grown in the simulated regolith, and they did fine. And in fact, if you had it probably with no dirt at all, it would look even better. The actual lunar regolith, they could make it grow. So the amazing thing was at least the lunar regolith didn't stop it from sprouting. It didn't stop it from growing. It did stunt the growth, however. And it obviously made them look very, very stressed. They could tell that from the colors. They could tell it by analyzing the DNA and RNA afterwards. Basically, they found that they reacted as if there were a lot of salts, which is probably true, metals that were there that were really stressed for them, and various oxidizing elements in the dirt as well. So it was stunted versus using the simulated dirt. And in particular, the other thing they found out was that these samples that the Apollo mission had taken were from various places. Some of them were, just on the surface, things that have been there for 1 billion years, soaking up cosmic rays, in particular being bombarded by meteorites, micrometeorites. So it's been ground down to a very, very fine level, and the chemical composition has changed. They found that stuff was the worst. That actually stunted the growth the most. If you just took dirt that was from underneath to the surface somewhere, you did better. So about the only real conclusion they can draw is, if you're looking forward to, in the future, trying to integrate a lunar regolith into something you're going to grow in, you're probably better off going for newer stuff, like lava flows, going underground, that sort of thing. That was their main conclusion. Some miscellaneous topics. OneWeb, we talked about this before, because of the loss of launches from Russia, they were scrambling and they had contracted with SpaceX to do a lot of their launches. But they went to India, and they decided that India could launch a few of their satellites. The details are not out there, but at least they're not all going to SpaceX. Everybody is scrambling. Really, SpaceX is kind of the only show in town after Project Kuiper came along and soaked up all the other rockets that don't work yet. They haven't even launched this particular rocket since 2019, so it's kind of a long shot. European Space Agency is continuing its replanning of missions. Well, the Russians have caused them great trouble because of the invasion of Ukraine. They had officially ended cooperation with Russia on all the cislunar missions, and they previously had already stopped the ExoMars. That's been delayed to at least 2028. It might never recover, really, but at least the earliest could be 2028. They need help from NASA for a couple things. First of all, the Russians were providing the lander on Mars for this, which is one of the hardest parts to handle. They need NASA help for that. The other part is having the radioactive heating. We have these plutonium-based heat sources, which we use on the current rovers. Turns out that's not so easy to get those anymore because the plutonium they used was a byproduct of nuclear weapons production, and we're not really producing a lot of that anymore. So they're saying, yeah, every 10 years we can build one of those. So there may be some other work that'll have to be done on this. Some other smaller items. The Chinese had 3 astronauts up in their space station. They've returned. There were 4 private astronauts that had gone up on a SpaceX mission sponsored by Axiom. They had returned. And the International Space Station also returned 4. So there's been a lot of activity going back and forth recently. One interesting side note is just showing how space-based stuff is impacting us more and more. There are now, according to Ukraine, 150,000 Starlink users. That is, users of internet service based on the satellites just in Ukraine. Now, it wasn't that long ago, there were only 150,000 users around the world already. So they went up pretty quickly. Now, that's based on about somewhere between 5,000 and 10,000 terminals. The current estimate is there's probably about 10,000 of those terminals there. Those went in pretty quickly, but it kind of shows you that even in the absence of a lot of Earth-based infrastructure, a lot of space-based stuff can start to have a real impact on the kind of communications with the military and civilian authorities there. Now we're ready to talk about launches since the last meeting. Now, the last meeting, we didn't find very many. I think we found 8 or something. Well, it turned out there were 3 that just didn't get reported right away. So I'm going to throw those in here. So there's 3 more than normal. So anybody want to take a guess as to how many launches we've had since the last meeting? And launches means launches to orbit or beyond.
1 million.
You're too high. Okay, I'll go ahead. Actually, it's a surprisingly high number. It's 18. I'll just highlight a couple of them here. I mean, most of them are pretty routine. Like, as usual, there's lots and lots of Starlink satellites that are being launched by SpaceX. One interesting one was that the Russians put up a rocket. It's called the Angara version 2. This is the first time they've made it to orbit. This project has been going on for 25 years. Their space program is kind of struggling, but at least they managed to get it up there. Oh, that's one. Another interesting one is on the bottom of this page. China, of course, is launching more and more things all the time, all kinds of satellites. This particular one was launched from a barge at sea. They're doing everything. They're launching from land, they're launching from sea. Anything that you think of, they've probably tried it. This particular one was launched a big barge. Another interesting one, the Electron. Now, this is the Rocket Lab rocket. It's a small one. They're actually one of the few that have been successful so far in the small launch business, but they were not reusable. What they've been doing, though, they've been planning on catching their boosters, their first stage booster, with a helicopter and net. Basically they go out there, the thing's coming down in a parachute anyway, so it's not that hard to grab it. So they grab it in the net and in the helicopter, and they actually managed to grab it. But the pilot thought that the load was a little heavier than he expected, and he got a little bit worried, so he went ahead and dropped it. Now, they recovered it in the sea anyway, but their goal is to recover it in the air, so there's no saltwater contamination, no corrosion. So they're getting pretty close now. Pretty soon they should be able to pull this off. The Chinese sent up an automated cargo delivery to their space station. Otherwise, a lot of these things are pretty typical. One interesting one maybe is the Chinese had one failure. They have a variety of startups. Now, their idea of capitalism isn't quite the same as ours, but they are trying to reproduce what happened in this country with lots of small companies launching their own rockets. And they had one. This particular one is called Hyperbola. It's from a company called iSpace. They've had several failures, and they just had another one. Okay, comments or questions?
What's your thoughts about the soil experiment that we did at NASA? About the growing the plants in lunar regolith?
Oh, yeah, they're gonna keep doing that. I think there's a little bit less to the story than it sounded like at first glance, because really they're just showing you can grow it. Just the fact that it doesn't kill the plant, I mean, that's progress. But the thing is, at least the lunar regolith apparently is not really outright poisonous, unlike the Martian regolith, where chemically it's really bad for you. But whether it can ultimately be groomed so that you can actually start growing stuff, is to be determined. They intend to follow this up, obviously. Yeah, Charles.
Well, I believe, as you said, there's obviously no organic material in lunar regolith.
Probably not.
There's never a source for it. So it's like, say, something to put organic material into. All plants, of course, have to store organic material to grow.
Yeah. So but the hope is at least they can take and they can use whatever's there. So that's just less stuff you have to bring from Earth.
So,
yeah.
So lunar regolith is essentially almost like saying,
it's glass. Yeah.
Like that,
Glass and little elemental iron and just all kinds of odds and ends.
I guess plants have a very hard time absorbing anything, absorb the elements of iron.
Yeah. But I think what's going to happen is there'll be a big program to figure out, okay, this is what we have. What can we do with this so that we can minimize what we have to import from Earth? Ultimately, that's still, you're going to have to do something. And even if you want to grow stuff out in space, in large colonies or something, it's still cheaper to get it there from the moon than it would be from Earth. So you'd really like to get as much as you can. Yeah.
On the same point, it seems like you said that there was a problem that a lot of the material was oxidated.
Yeah, I don't know what the compounds were. I saw reference to that in the paper, and I didn't.
Okay, well, was there any talk about just exposing it to ozone and basically burning that stuff up and turning it into various forms of rust?
Well, they didn't. Yeah, they didn't go that far into amelioration of the problems. They were just their big thing was just highlighting.
Easy problem to solve.
Yeah, that one seems like it would be.
Just oxidate all.
Agreed. Yeah. Well, it means you do need oxygen, but yeah, if you got water there, ultimately you got oxygen. Okay. I think we're ready for the speaker of the day, Charles Phillips. Now, he's the head of his own company. He does a lot of research. In fact, maybe he's proposed projects with some of these government agencies before. He's worked on a space station and space shuttle. He also has been a flight controller at Johnson Space Center. There's a retired lieutenant colonel in the Air Force. He used to work as an orbital analyst for the Air Force, both in Cheyenne Mountain, NORAD, and also in Alaska. And he has degrees in space operations and physics and math. And with that, I'll turn it over.